All right, guys, what we're going to be doing this evening is going over the summative review. I just want to walk you through a couple of these problems that we did have a number of questions pop up while we were doing this. So if you want to follow along, I already have some of these notes here, so I'm going to get rid of those really quickly, erasing some of this so that I can really show you what exactly is happening on some of these problems. Now, again, all of these problems are pretty closely aligned with what you're going to see tomorrow on the summative, so we want to make sure that, oh, that's not what I wanted to do. We're going to make sure that you're feeling reasonably comfortable with this. So I'm going to zoom in really quickly and go problem by problem. Now, problem one, what is the function that models this exponential equation? It's very simple. All we do is this. We say, great, what's my starting value? Well, it's 1. By starting value, I mean, where does it meet? Whoa, where does it meet this being the y-axis? So as we look on that, we say, where is the starting value? Well, that's 1. So we know that y equals 1 times, I'm going to make these parentheses, and then we go and we look at where x is 1, because that's going to be the easiest one. Well, that's x is 2, that's x is 3. At x is 1, we see that the value is 2. So I asked myself, what can I multiply 1 by to get 2? Well, the answer should obviously be 2, and it's all to the x power. And you can see that that's still true because then 2 times 2 gives me 4, 4 times 2 gives me 8, we're proceeding there. You can also check by going backwards and saying, okay, 1 divided by what gives me roughly 1/2? Well, the answer is still 2. So that's how you do that one. Oh, I'm used to OneNote. So now we scroll down and we say, okay, what is the function that models this linear inequality? Well, the way that I do this is by simply saying, okay, what is the y-intercept here? Well, the y-intercept, as you can clearly see, is -1. -1. And then I can check the slope by saying, great, well, it appears to go up 3 over 1 to the next corner. Up 3 over 1 to the next corner. Same thing is happening if we go backwards. Now, we see this slope there, meaning it's up 3 plus 1. So my slope is positive 3x. And now, the last part, this shading piece, this is what's been killing us, and I want you to see this really quickly. The thing that's been also killing us is saying, okay, well, once I have my line, I want to figure out how to make this work. So I'm going to make it very simple. The inequality is facing away from y, which means I'm shading underneath it. So I can find anywhere on my function line. I'm going to choose right here, because why not? Under, I shade downward, which means I'm shading underneath it. Now, if it were facing the other way, I would have done the same thing, but drawn an arrow upward. And the last thing is it is a dotted line, which means it is not less than or equal to or greater than or equal to. If there's a solid line under, it is a solid line. Great. So as we scroll down, we're going to see which of the following ordered pairs is not a part of the solution. Meaning, I can plug any of these values into this equation right here, or inequality rather. Oh, that shifted all around. That inequality being y is less than 2x minus 6. I can choose any of these values and plug in my x and my y, and hopefully that should be fairly simple to see. So we're not going to spend a lot of time on there. I'm going to scroll down a little bit and write an equation for a line with a slope of -4 over 5 that contains the point -5, 6. Now, this is one that is killing us. So watch up here. It's going to be very, very simple. We can write y minus y sub 1 equals mx minus x sub 1. We know that the slope it gave us was -4/5. we know also that the point it gave us, so the coordinate was -5, 6. Now it's very, very simple. This is just like plugging things in. Just pretend it didn't do that. Just plugging things in. It's just going to be like that, huh? So I'm plugging all these values in. That's my x, that's my y. That is my m. So I say y minus 6 is equal to -4 over 5 x minus -5. Well, the first thing you should see, hopefully, is, hey, mister, that needs to be plus 5 because minus a negative. Then we distribute. This is actually not super difficult math, even though there is a fraction, and I'm sure some of you are not super jazzed about that. You're going to get -4 fifths x. -4 times 5 is -20 divided by 5. Well, -20 divided by 5 is -4. And then the final step, plus 6 plus 6. And I arrive at y equals -4 fifths x plus 2. And that is now in slope-intercept form because it is in the form y equals mx plus b. Now here's a fun little part that I'm going to tell you on here. If you write these following things on the top of your summative, write these things on the top of your summative, I will happily give you a couple extra credit points. Y equals mx plus b, that's slope-intercept. Write standard form, which is ax plus by equals c. Finally, write these two. Y minus y sub 1 equals m, if I can write this correctly, m times x minus x sub 1. The last one you need to write is y equals a times b to the x. Now, if you write those on the top of your summative, we will happily toss you a couple extra points. Now, I'm sure some of you were probably still confused by the multiplication up here. -4 times or over 5 times 5 means I get -20 over 5, which is -4. Great. So that is how we got -4 fifths x plus 2 is equal to y. Now, which of the following pairs is the y-intercept of the function? Well, the way we would do that is we would say x is 0, 1/2 to the 0 power is 1. 1 times 12 is, of course, 12. So 0, 12. Now here, in order to do, let me do this in blue. In order to do this, I put it in the simple form. B, or the balance, is equal to the principal, which in this case is $100, the beginning amount, 1 plus 0.06, because that's the rate, divided by the number of times it compounds per year. Hey, Deep. The number of times it compounds per year raised to the 12t power. And the only thing here is I would put 100 for the principal. I need to be careful with these two pieces. I'm going to highlight them so you see what I'm saying. You need to be careful here and here. Make sure you know how many times it is compounding per year. My goodness. Okay. Come back down here. We say, great, Mr. Gibson bought a Mercedes-Benz for $75,000. The only thing that might trip people up here is making sure that they are not putting 0.15. That is not a 15% decrease. That is an 85% decrease. We need to do, as Mr. Gibson has shown us, 1.00 for 100% minus the 0.15, which gives us 0.85, also known as 85%. Now, we come down here. This one tripped us up quite a bit. The table below represents the values when x, we need to find when the value of of x when f of x is 512? Well, I can simply make a table. It's going to be 4, 64, so on and so forth. Eventually, when x, the input, is, when the input is 7, it's going to yield an output of 512. All right, guys, sorry for the pause there. I had to go finish making my dinner. All right, so next we are looking at number 9. A situation is modeled by the function x of t is equal to 6 times 3 to the t power, where t represents time in years. What is the average rate of change for the first 4 years? This is the simplest way to show this. F of 4, because we want the last value here, minus f of 0. What we're doing here is, if you want to see the table, we are saying, I want to find x and y. I want to find from 0 to 4. Well, when f of 0, when I plug that in, I get 6, and f of 4, I get 486. Well, from here to here, it's 480. Here to here is 4, which means the slope of that line would be 480 divided by 4, which is 120. Now, that is only an average rate of change. This is still an exponential function. That is just the average rate of change, meaning if we were to look at this in terms of come down here and draw one of these, in terms of a function line, what it's saying is, here's my function line, and it wants to find from this point to this point the average rate of change. Now, you don't know calculus yet, so you can't calculate this full line. What you're doing is drawing a straight line between these two and telling me the average rate of change between that. So we're kind of ignoring a bunch of this. That is, in essence, what is happening up here. Now, we're given 2 coordinates. If the slope of the line passing through these 2 lines is 2, or these 2 points is 2, determine the possible answers for y1 and y2. The idea here is this. We know what the bottom, or the denominator, of our slope is. It is 5, because 3 to 8 is 5. Meaning, the numerator, y sub 1 to y sub 2, needs to be a difference of 10, because 10 divided by 5 is going to yield 2, which is what it says right here. Awesome. So we're back. The idea here is that I need to be able to determine what would give me a slope of 2. So from 3 to 8 is a difference of 5. I know that the only thing that's going to divide by 5 and equal 2 is 10. So all I need to do is determine a y sub 1 and a y sub 2 that have a difference of positive 10. So personally, because I like being lazy, I would say 0 and 10. That's the easiest one. Now, I cannot, remember, cannot say 10 and 0, because that would give me a slope of negative 2. So it would need to grow. Since 3 to 8 is growing, this would also similarly need to grow. Great. Great. So Alec, Brad, Joe, and Jim, and Tom are Broncos superfans and were listening to fan radio and heard a rumor that Von Miller was being traded, so on and so forth. It started with 5 people. They each told 2 people, so 5 times 2. It wants to know on the 7th day, therefore, to the 7th power. It also wants to know when it would cross 100. Well, the easiest way to do that, since you don't know how to solve for logs yet, oh my goodness, what is happening here? Since you don't know how to solve for logs yet, is simply to make a table, x, y. Well, 0, 1, 2, 3, 4, 5. So I would start off with, well, at 0, it's 5 because 2 to the 0th power is 1 times 5 is 5. 10, 20, 40, 80, and 160, meaning on the 5th day, more than 100 people have heard it. And on the 7th day, 640 people have heard the rumor. Great. And come over here, and we say, fantastic. Jordan can spend at most 25 on red cows and red cows and Tukis, which are chips. Red cows cost $5 each, and Tukis cost $2.50. Write an inequality, graph the solutions, label the axes, identify one solution, and explain it in a complete sentence, the real-world context associated with that solution. Well, pretty easy. Let's start off by saying, great, pretty sure that's 5x plus 2.5y is less than or equal to $25, because that's all Jordan has. Now, very simple ways to go about it from here. I can do one of two things. First thing I can do is call the cover method. Hey, Deep. First thing I can do is call the cover method, where I'm going to zero that out and say, great, 2.5y is essentially equal to 25. Well, in order to solve for y, I would divide, find out that y is 10. And then I can do the exact same thing. And back at my original equation, I can say, cool, that's similarly 5x. Then I can block this out, do the same thing, and find out that x is 5. Now I want you to keep that in mind while I show you the other way that you've already learned. So we have 2.5y, 5x plus 2.5y is greater than, or I'm sorry, less than or equal to 25. I subtract 5x from both sides. After subtracting 5x, I'm left with 2.5. Y is less than or equal to negative 5x plus 25. Well, it's not happy about that. Then I divide by 2.5. And I'm left with y less than or equal to 5 divided by 2.5 is negative 2. It's a negative 5. So negative 2x plus 25 divided by 2.5 is 10. Well, let's see how that works out when I go in and graph this. That's why I don't use Word all the time. Well, that means I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. The solid line, because it is less than or equal to, and then I see that the inequality is facing away from y. So as we previously discussed, I'm going to put my pen anywhere on here, draw downward. That is the side we shade. Meaning anything contained within there is the solution set. Now, let's say we choose 1, 5. That means Jordan could buy one red cows, because that's what we labeled here. And I should actually do it on here. That's terrible of me. I'm sorry. Red cows. And this is Tukis. I could buy one red cow and 5 bags of Tukis for less than $25. I could have also chosen any of these points, but I need to explain them in context. The exponential function of f of x is 5 times 3 to the x, is graphed to the left. Identify the range and domain of this function. Well, range and domain are very simple. Domain indicates where it could be on X. Well, there's no limit on which way, left or right, this function can go. It is all real numbers. However, as I've stressed about 1,000,000 times, and I'll do this in red, there is sure as heck a limit on where it can go here. It can never equal 0. It can never equal 0, meaning the range is y is greater than 0, not, and hear me very carefully, not greater than or equal to. It is not that, because there's no exponent that you know at this point in time, or really in existence, where you can multiply it and get something that is 0 and then something that is not 0. It has to be greater than, not greater than or equal to. Okay, which of these 2 points lies closest to 0? Well, the 2 that everyone in class today came up with were these 2. That one is just 1 over 1, 2, 3, 4, 5, 6, 7. Meaning, line BF is 1 over 7. I don't really like that though, because line CE is plus 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Line CE is 1 over 12. 1 over 12 is much closer to 0 than 1/7. Therefore, that is the correct answer. Which dataset models a linear function? Well, hopefully you can see this very quickly, but this is increasing by 2 every time, plus 2 in the numerator. This is increasing by 1 every time, so the slope is plus 2 over 1. Except I misspoke. I apologize. That is minus 2 over 1, because 1 to -1 is -2. Explain whether this is a linear or exponential function. Minimum 3 pieces of evidence. Well, if you presented this to me today, I most likely told you the exact same thing. But mister, that went up by 15, and this only went up by 5. Therefore, it can't be linear. And many of you said, nope, that went up by 3, that went up by 1. And 15 over 3 is in fact equivalent to 5 over 1. Therefore, it is linear with a rate of change of 5 over 1. Cool. Same thing here with the average rate of change. I'm going to erase all of this really quickly so that you can walk through this with me. Again, keeping in mind, and this is one of those average rate of change problems again that we had some trouble with. Please make sure that you are watching very, very closely. So, it wants the rate of change from 0 to 10. I'll do that in blue. 0 to 10. And then it wants the rate of change, which we'll do in red, from 30 to 40. Let's check these out. In blue, from 0 to 10, looks like it goes from 1,000 to 1,500. This is for you to see the table. That appeared to be about 500 in terms of an increase. And it went up. That was the change in y, and the change in x was 0 to 10, meaning plus 10. Well, 500 over 10 can be simplified to 50. Now, again, what we just did here is we said, great, I don't know calculus, so I can't calculate the exact length of that line, but I can kind of fudge that line right there with 50. I'm going to do the same thing in red. I encourage you to try following along. So we can see that it starts at about 3,500 and goes to about 5,000. And again, it went from 30 on the x to 40 on the x. Well, that's an increase of plus 10. That's an increase of plus 1,500. Well, 1,500 divided by 10 is going to end up giving me roughly a rate of change of about 150. Down here, hopefully you remember, this was 50. Now, the next part of the question is, yeah, but why is it different? And your answer should simply be exponential equations and exponential functions change their average rate of change over time. That's just the nature of them. And then finally down here, hopefully some of you saw how to do this during class, but just to make sure. That increase was, well, 150 to 640 is going to be about 490, and this was 7. Well, 490 divided by 7 is 70, meaning my slope was 70. But the biggest mistake people are going to make is they're going to forget that they need to take it back to 0, meaning I can't say 150 is my starting point. I need to subtract my slope here, which is 70, which is going to yield me 80. Hopefully that was helpful. Please let me know if you do have any questions, and I'll see you tomorrow.